Hello and welcome back to episode 7 of the DC2 Racecar build. It's been a while since the last one. It's been lots of little fiddly jobs, so they've taken up heaps of time. I'm also about 30 hours deep into planning the wiring harness, which we'll get to later. It's been a learning experience. I haven't done it before and there's a lot to it. And me being me, I've made a giant spreadsheet to make my life easier. Just on the car itself, so a bit more done to the engine bay. Got the Skunk 2 intake manifold. That's had a adapter plate welded to it for Bosch drive-by-wire throttle body. I think it's a 68mm throttle body. I definitely want to run drive-by-wire. It makes things a lot easier. You can have auto blip on downshifts and way better idle control. It's just an all-round better solution. Fuel rail was on. Just got the stock injectors in there for now. I've ordered some Bosch 1000s to go in there. Radiators mounted. Hoses are run. Just a basic setup with some 90s in a straight. Not too much else in the engine bay. I have measured up and ordered all the fittings for the fuel lines and the catch can lines. That'll come through in the next episode, I think. And outside of that, there's not really much left in the engine bay itself, apart from the wiring, which I'm doing, and just dressing it out with headlights and all other bits and pieces that are still missing. Also installed the shifter and cables, so we can see the cables running through here, the APS through the firewall. And up to the Acuity adjustable shifter. This thing's a beast, it's really nicely put together. I just picked up a sort of cheap gland off eBay. It was about $20 to go through the firewall. That's turned out pretty nice. Shift feel was pretty nice and positive, which was what I was after. Not too much else in the interior. I've got the seat back in and I've also got the throttle pedal installed, so I'll wander around there and show you that. So this is a Bosch drive-by-wire throttle pedal position sensor. It actually wasn't too bad to get that mounted up after all. So you can see I've bolted it just to the right of where the factory accelerator pedal goes. And because there's a bend in the pedal, it sort of brings it out to pretty much where the factory pedal was. It's a little bit to the right. That doesn't worry me. I've got wider pedal pads. And like I mentioned before with the electronic throttle body, I have auto blip downshifts anyway, so heel toe is not a concern. But it does still work. So a pretty simple bracket. It just bolts into a couple of locations into the factory sort of sheet metal, and then the pedal just bolts straight to that. Had to get in there with a hammer to make a little bit of room for the connector up the top. It was just a couple of taps with a mallet, got the sheet metal out the way, all good. On to the wiring side of things. I've made a mount to capture my ECU and PDM. That's just a sheet of 3mm carbon fibre. There's some U-bolts attaching that to the roll cage tubing, which I'll chuck in some photos of. And also got little rubber isolator mounts, which are between the carbon fibre and the ECU and PDM. That's super important in a race car, especially a K-series race car, because those engines vibrate like shit. So yeah, it really helps prolong the life of your electronics. Pretty nice, neat solution. Pretty happy with how that turned out. And it's in a good spot out of the way. The co-driver or any passengers, they could theoretically kick it if they want to, but they'll have a foot box in here as well, which will have like a plate for their feet to push up against, so their feet shouldn't be wandering anywhere near that. So what I'll do now, I'll jump across to my computer and start running through the wiring planning that I've done. And after that, I'll be sort of running a dummy wiring loom through the car just using rope to figure out all the lengths and the layouts. And that'll probably be it. After that, I'll then order all the materials and get the harness built up and installed. But that'll probably be in a future episode. Okay, welcome to my computer. Let's have a look at what I've done for planning the wiring. To start with, I'll go through what I'm using for electronics. I've got the Haltech Nexus R3 ECU. I did originally have an Elite 1500, but when the R3 came out, it was a much better solution, so I've sold off that and grabbed an R3. Super good concept of combining sort of a small PDM with an ECU itself, so it can control most of the engine side of things. It's got 425 amp circuits and up to 6 8 amp circuits, but I use a couple of those for the throttle body. And the rest of the specs are pretty similar to the Elite, so 11 analog voltage inputs and up to another 5 or 6 if using unused SPIs, and everything else that I need to run a pretty simple 4-cylinder engine. That doesn't have enough power sort of management to run the whole car though, so I've also got a Haltech P16 PDM that's got another 4 25 amp circuits and I think 10 or 12 8 amp circuits on top of that as well. Combined, they just cover everything to keep the car running. I've got a pretty comprehensive set of sensors in the car. We'll get to that when I get to the spreadsheet. But between the two, they do a pretty good job, and it's pretty economic as well. So combined, these are probably something in the region of 5,000 Australian dollars, compared to something like $12,000 to $15,000 for an equivalent Motec setup, which is a massive jump. And for me, I just don't, nothing. The Haltech does everything that the Motec does for me because I have a very simple engine setup. So no real need to go super fancy. So to start with, what I wanted to do was essentially just list all the things that I need to cover in the wiring harness. I don't really know anything about doing this. This is the first time I've done it, so the High Performance Academy courses were super handy, just doing their club level like wiring fundamentals and club level wiring course. That taught me quite a few things, some things to look out for and rules of thumb. But with myself being an engineer, I love spreadsheets, so creating a giant spreadsheet to capture all of this was always a given, and it has, I think it's definitely made it easier, but it's taken a lot of time. I've probably got 20 or 30 hours into the spreadsheet by itself, including heaps of research to learn stuff along the way. So step one for me was to list everything, all the inputs and outputs, so everything that needs to be on the harness and controlled or included. So I broke that down into areas. So I started with the engine and transmission, excluding the sensors. So this just covers things like the ignition coils, the fuel injectors, the throttle body, and the various small bits and pieces like the alternator, starter motor, and the solenoids that run the VTEC and VTC systems. And what I did for that is just looking at inrush and steady current draw, just looking up the specs of things online to figure out what that was. Figuring out the drive side, this is a concept that I had to learn. So high side drive means you switch the power to turn it on and off, and low side drive means you switch the ground to turn it on and off, and there's reasons for doing that, but high side drive is the easiest way to go for me, but a lot of the stuff uses low side drive for reasons, but I won't get into it. Also identified what the pinout type was, so the type of function that needs to control this from the ECU or the PDM, and just noted down what the actual physical thing was. So like my OEM coil packs, Bosch injectors. I've actually ended up going with a 1000cc injector now just for a bit more headroom, Bosch throttle body, and so on. This pinout reference all came later once I'd done the second tab, so we'll get to that later. Second section was all the sensors. So starting with all the sensors that you need to run the engine. So manifold air pressure, which I'm using the onboard map sensor on the Haltech. Intake air, a fuel sensor, oil pressure, and coolant. So the reason these are all pressure and temperature, especially for things that aren't super common like that, like fuel, is because Bosch does a really neat combined pressure and temperature sensor. So it's just one sensor that does both functions. So might as well just grab a couple of those to cover the fuel and coolant as well as oil. And then we have the position sensors. So you have a crank position sensor and you have 2 cam position sensors. The reason the K20 has 2 cam position sensors is the intake cam is variable timing, that's the VCT. And so what it does, the engine uses the exhaust cam position, which is static or doesn't change, to know where the engine is, and then it also needs the intake cam position in order to move it around and change that timing with whatever the tuner inputs into it. Got throttle position sensors. So with drive-by-wire, you have redundant sensor systems. So you have 2 throttle position sensors and 2 pedal position sensors, which is all integrated into the pedal and the throttle body itself. Knock sensor, obviously. I'll swap out the stock one to a Bosch 2-pin style sensor. Wideband oxygen sensor, of course. Ethanol content, because I'll be running this as full flex fuel. Fuel level sender, just using the stock fuel level sender in the stock tank. Vehicle speed and reverse engagement from the gearbox. Clutch switch on the clutch pedal, so that'll be used for things like launch control and also flat shifting. And brake pressure sensors for the front and rear brake circuits. These are quite handy from a data point of view, so very happy to have those in there. Same with the rest of this stuff. So some of these are future, I haven't bought any of it yet. But steering angle is quite important to know, so understanding what you're doing, into and through a corner. And also damper travel, so that really lets you get into the weeds of how your suspension is working and how you can tune it. These will be a future thing. I'll sort of get the car up and running first before I get into that level of data analysis. And in future, I'll also look at tyre pressures and temperatures. Haltech does a neat sort of CAN solution for tyre pressure and temperature, which has internal sensors on each wheel. But it only gets you a singular temperature. It's not an array across the tyre, which is the handy bit that I want. So I'll probably look at something like an Izzy Racing setup, which has an array of temperature sensors, like infrared sensors that shoot temperature across the tyre. And that's super handy for seeing what your tyre's doing in the corner. Lots of sensors. That's 41 different sensors in total, all for a simple little 4-cylinder. Next is the chassis side of things, which is split into forward of the firewall and rear of the firewall. So forward of the firewall in the engine bay, we have the fuel pump for the surge tank, because the surge tank's in the engine bay. Have the radiator fan, have all your headlights and your indicators, and just wiper and horn, pretty basic stuff. And here I'll just call out that I've got a light bar. So a lot of the events that we do here, tarmac rally sprint, are held at night and not very well lit areas, so it's pretty essential to have a light bar to see where you're going. And every other bulb in the car will be LED as well. One, you get better light output, but mainly it's because the current draw is so much lower than an incandescent bulb, which is very much needed when you're sort of trying to pack a whole bunch of them onto a single PDM circuit. And down to the interior side of the chassis, we have the fuel lift pump in the main tank. We have heated windscreen, so I've gone for a windscreen that has integrated heater circuits, so much like a demister circuit you have in your rear windscreen in most road cars. You can get versions of that for front windscreens. It uses a tungsten element, which is apparently pretty well invisible, and they work quite well. And because I don't have a heater or anything in the car, this is pretty essential whenever the weather's going to be bad. And I don't really want to try and rig up a 12-volt heated blower setup. It's just not going to work very well. So I'm looking forward to the screen. It is pretty grunty. It uses 2 25-amp circuits. I need to have a CAN hub to connect all the CAN devices in the car. Things like the keypad, that's all via CAN, and that will control the entire car. My data logger. In future, I'll have a dash display, but for a start, I'm just going to use the data logger because that can show me pressures and temperatures as well. Things like a USB power hub to run, cameras or charge batteries or whatever I need, and all the rear lights. Because to start with, I'm not going to run a proper dash display. I'm just going to use the data logger. I do want a warning light, so Motec does a nice 2-stage LED warning light. So when, while I can see temperatures and pressures on the data logger itself, I do want something to flash at me whenever something gets into a bad state. So I'll set that up so that the ECU triggers that whenever temperatures get too high or oil pressure gets too low or whatever it might be. And that'll be super handy because it immediately draws my attention to it and I can back out of it. There will also be strategies programmed into the ECU to cut power in the event of low oil pressure or all sorts of things. So just the general safety. So once I created that big long list of everything that I want to include in the wiring harness, what it needs to connect to and from, then translate that to this next tab. So essentially what I've done here is break down every single pin on every connector for the ECU and the PDM And if we jump across to the wiring diagrams, we can see Haltech's done a really good job of graphically laying this out. So I've kind of just taken all that and turned it into a spreadsheet so I can assign all my inputs and outputs to it. And also things like wire colors and coding, because I do it slightly differently to what Haltech does. So that's the one for the R3. This is the one for the PD16. And that's just all translated across into one big list of connectors with all the different pins and their functions. These all have a primary function, obviously, but some of them will have a secondary function. So for an example, the unused injectors, you can use those as digital pulsed outputs to control whatever you want. I just don't have that much to control, so most of those are left as spare. So to generate this list, I populated all the pins and that based on what the wiring diagram says. And then I started just assigning things from the inputs and output sheet to this list. So the 4 fuel injectors, give them a reference back to that list on the first tab, bring across their current and so on to calculate wire size. And just repeated that through every connector through the ECU. So we can see here they're all pretty populated, or they're shown as spare. That was quite a lengthy process to get that right. With the amount of sensors that I'm running, I've maxed out all of the analog voltage inputs, and because they have a synchronized pulsed input, which you can also use as an AVI, maxed out all of those across the PDM and the ECU to get all the sensors in, but it just works, which is good. From a power circuit point of view, I think I've got 3 spare 8 amp circuits left, and I haven't been particularly efficient or optimized with how I've used the other ones, so there's quite a lot of room there if I ever need to integrate more things into the system. So yeah, like I said, I've populated all that. Some of these pins have a heap of connections, like the sensor ground, for example, has all of the sensors attached to that same one pin, so they're just like a massive branch point right after that. Same with sensor supply. And moving into the power circuits, the Nexus R3 has 4 25 amp power circuits, so that runs basically the engine side of things, so it runs the ignition coils, the starter motor solenoid, the main fuel pump and the surge tank, and the radiator fan. It would also run the fuel injectors if they needed heaps of current, but they're pretty low current ones, so just a normal 8 amp output and the ECU can run those. And down onto the PD16, we have split all the circuits up by sort of area of the car and function. So all of the headlights and all the stuff that happens when you turn your low beam switch on, that's on one circuit. So your headlights, your tail lights, and your number plate lights. Each side of indicators is on its own circuit. Brake lights are on their own circuit. Reverse lights, rain light, horn, and so on. The PDM can take a few sensor inputs, so I've done that as well. So that's things like the fuel level, the clutch switch, steering angle, and the damper travel ones, which I'll put in future. And the 25 amp circuits on the PDM, that's running the fuel pump in the main tank, the headlight high beams, which includes the light bar, so together they draw a fair bit of current, and the 2 circuits for the heated windscreen, like I talked about earlier. So once I generated that big list, I knew everything that I needed to connect, and I knew where I needed to connect it to. So now it's time to look at stuff like the wiring colors and just coming up with like a code so I can understand what's going on in the harness. And very professional level harnesses, they just use all the same color wiring, and their planning and their diagrams tells people what's what. I'm not that good, so I want something that visually tells me which wire is which. So to do that, I've kind of slightly modified the Haltech way of doing things. Back on this screen here, I've got my references. So this wire color key is taken straight from the High Performance Academy course. So every power wire will be red, every ground wire will be black, every sensor ground wire will be green, every sensor power wire will be orange. They run on their own dedicated circuits to minimize electrical noise. And literally everything else will be white. So all of your sensor signals, everything will just be white. That makes for a lot of white wires, which is hard to tell what's going on. So then what I've done is referring back to the Haltech wiring diagrams. You can see they have their own colouring system with their wires. They have a primary and a secondary colour. And what I can buy is tiny little wee rings of heat shrink. So there's basically like a 2mm or a 3mm length of heat shrink that come in heaps of different colours, and I can use those as little like colour codes to attach to each wire. And I've done that basically with the same colours as the Haltech. So the wire code key, all the different little heat shrink rings come as these 10 colours here. And what I've then done, if we go back to this tab, is the wire code. I've basically just matched that to Haltech. So things like fuel injectors, that's a white wire because it falls under the everything else category. But to identify which injector is which, I've just used the Haltech codes. So blue, blue black, blue red, and blue orange. And that matches exactly what we've got set up here. So blue black, blue brown, and blue red. That's probably like not an exact match, and the reason I've done some slight discrepancies from it is to avoid double ups, because between the R3 and the PDM there are some things that are kind of the same between them, and because I've got one integrated harness running both devices, I did make some small changes to avoid double ups. So I went through everything and assigned all of that. Heaps of different codes. I ran some checks to make sure there was no double ups and got that all set up. So once that's all built, I can look at any wire in the system and understand straight away pretty much exactly what it is by looking at the color of the wire and the little code tags on it, and I can just cross-reference that back to this list and figure out exactly where it is. Next step after that was to look at the downstream connectors. So obviously at one end it connects to the ECU or the PDM, but at the other end, what does it connect to? So I just went through each item by item and just identified what that connector was. So whether it's the OEM connectors, and you can actually buy all those new, which is super handy. Whether it's like other ECU connectors, whether it's the DTM, Bosch, all the different types, just depending on what the device is that it's connected to. Also, where I did know or could find out, I put the pin reference for those downstream connectors. So it's a pretty comprehensive list of exactly, whatever pin on the ECU or PDM goes to whatever pin on any device. You can find any info you want out of the spreadsheet. So that all took a pretty long time. Like I said, I enjoy large spreadsheets. This is how my brain works. So now I have one big comprehensive, repository of information. And that'll be perfect for building the harness from this. The next steps after that, once I've got all this together, is to actually physically understand what the harness looks like and where it goes, so I can calculate, wiring lengths and order all the right bits and pieces. So in a second we'll jump back into the garage and have a look at what I've done to dummy up the wiring loom. But just in the meantime, I'll just have a look at keypad layouts. So I mentioned before that I've got a 15-button keypad which will control the entire car, and there are more things I want to control than buttons on that keypad. So I had to have a good think around how might I combine some of those things to get everything that I want. So I think I ended up with like 19 or 20 different functions on a 15-button keypad, which is pretty good. So this version 4 over here is probably what I'm going to go with. This keypad we mounted in the center of the car, pretty much just in front of the shifter, I think. I haven't designed that yet, but it's about the right spot to put it. So that'll have like the indicators, the hazard lights, headlight low and high beam toggle, headlight flash, which is something I want to do just as I think it'd be amusing. So if you ever watched Le Mans and other endurance races where they have many different classes of differing speed cars, they have a fancy headlight flash sequence that sort of lets them know that somebody quick's coming up behind them. I'm presuming my car will be quick, which is probably getting a bit ahead of myself, but it'll be a good bit of fun. Pit speed limiter, can chuck that onto whatever it needs to be. Rain light, wipers, the windscreen demisters, horn, and then this stuff down here is all manual stuff, so I can manually activate the radiator fan if I want to keep it cooling after the car is off. Can manually activate the fuel pumps if I want to drain the tank, which is super handy for switching between 98 and E85. Obviously got to start the car, toggle data logging or reset the engine warning lights if they pop up, and then vary the launch control RPM. I don't have an ignition switch on that. What's sort of not included in all of this is there'll be a solid state battery isolator, probably a Tyco one, and that has its own buttons which triggers it. So I'll just flick that button to essentially activate the battery system, and then everything's powered, and I just press start to start the car. Anyway, that's about it for the summary of wiring planning. Like I said before, it was a pretty lengthy process, and I had to learn a lot of stuff along the way, which has made it take quite a long time. I've already seen a number of ways I can improve this for the next time if I ever do another wiring harness like this, just to make it a bit more efficient and clean as to how it's all laid out. But now I essentially have all the information that I need to start building the harness. So yeah, like I said, we'll jump into the garage, we'll have a look at the dummy harness, and then down the line, in a future episode, I actually start building it based off all the materials I've ordered from that dummy harness. So yeah, let's jump across to the garage. Alrighty, so I've just run the dummy loom throughout the car. That took a couple of hours to find all the right spots. Again, like I said before, just using rope to do this and a bunch of masking tape to identify each point and sort of find all the branches, connect them together. So out of the ECU, we've got the different connectors, same with the PDM, that runs up to sort of like a main branch point. Out of that, we've got two bulkhead connectors. Two connectors because one will be dedicated to everything connected to the engine and the other will be dedicated to everything connected to the chassis. It just keeps it nice and simple. To remove the engine, it's just the one connector in the bay. Also feeding over to the steering column, so I've got a clutch switch, the drive-by-wire pedal position sensor, steering angle sensor, and the CAN output for the dash, and also the right hand side marker indicator goes over there as well. Coming back through the car, we head out towards the back and we get to the fuel pump in the main tank, the lift pump, as well as the fuel level sender. And then we head off up towards the rear of the car where there's going to be a connector to all the rear lights. I'll probably just use the factory loom for the rear lights and just replug it. And that sort of just catches there on the back. I also have a connector for the rear damper travel sensors. When they get installed, they'll run out from that area too. So that covers the inside of the car, and then we'll get to the complicated bit, which is the engine bay. So there's a lot going on in here. Like I said before, I've got two bulkhead connectors. Bulkhead A is for the engine, bulkhead B is for the chassis. So starting with the chassis, firstly we get power running up into the fuel pump in the surge tank, the main fuel pump. Then continues around, picks up the ethanol content sensor and also the front left damper travel sensor. Travels through to get to the left hand lights. I'll probably just have a master plug there which goes off into the different light circuits. We'll then run across the radiator. It'll run underneath the core support. I just sort of mocked it up on top because it's easy. About halfway along that, it dips down and runs to the horn and also the LED light bar, which I run for nighttime tarmac rally sprint events. And on this side, we branch off into the radiator fan and the front right lights and the front right damper travel sensor. The other half of the chassis harness will run up to the brake pressure sensors just there, and then further along up into the wiper motor. So that covers that one. Not too much on it, but still a fair bit. Back to bulkhead A, running all the engine. So that basically jumps straight across to the engine and got a pretty major branch point which goes to a whole bunch of different places. So we've got the reverse lockout solenoid, we've got the two cam sensors, we've got the engine coolant temperature sensor, got the vehicle speed sensor, and then down to the reverse engagement sensor to run the reverse lights. We also head up into the ignition coils, so we've got 4 ignition coils. Then out the back here behind the head, we get to the VTEC solenoid, the oil pressure and temperature sensor. Down here we've got the VTC solenoid, the variable sort of cam timing, I guess. And also down the bottom is the crank sensor. Coming back along, we then branch out into the fuel side of things. So we've got all 4 fuel injectors as well as a fuel temperature and pressure sensor, which will go into the fuel rail underneath. Then branches out into the throttle body itself before going underneath to capture the knock sensor, the starter solenoid wire and the alternator field wire. As you can see, heaps going on. It's going to be quite complex to build. The next step, after I've sort of double checked all this, I'll go back and verify it against my giant spreadsheet just to make sure I've captured everything. I will better carefully pull it out of the car and start measuring all the lengths. And the output of all of that is a very complex little diagram like this. So this captures every single branch point and every single sort of end termination in the loom. And when I measure all the lengths, each one of those lines will get an individual length. And then when I'm calculating how much wire I need and building the harness itself, I can essentially just set it up and add together all the different measurements between, say, ECU connector A and coolant pressure sensor. It'll do its thing to find where it needs to go, add it all up, get one big length, and then I know how long to make the wiring. So that's about it for wiring planning. Yeah, like I said, I just need to go verify everything, make sure it's all good, then order all the materials so I can get stuck into it. I'm sure it'll be horribly expensive to buy everything I need, especially the bulkhead connectors. Not looking forward to that. They're probably $300 each at a minimum. But needs to be done. I definitely don't want to have to run a giant grommet through the firewall. Yeah, so that wraps it up for this one. Over the next few weeks I'll just keep working on wiring, so hopefully the next episode will have some harness building in there. Outside of that, there's not a hell of a lot left to do mechanically. You've just got to get the fuel system, all the fuel lines in, and little things like install the axles and install the fuel tank, a few other minor bits and pieces. So yeah, thanks for watching. See you next time.